doing yet another virtual contest today. Today I'm doing ARC 133. I haven't done very many ARCs, but let's see how this goes. So virtual participation. Well, you have to set the time, right? 20. Why? Why you do this? What is this? So stupid. Alright, 47 seconds. Alright. I just have to wait. I don't need this anymore. 35 seconds. Alright, hopefully today I can do good. Oh yeah, so like today there was like a Code Forces contest. It was oh, this is a little loud. I like the Real Life OST. Shoot. So today there's a Code Forces contest. Oh shoot. Well, I'll have to explain afterwards. 8 seconds now. But in the Code Force contest today, I had a good clutch. So like hopefully, you know, in this contest, I can like end up doing good too. Alright, it doesn't automatically go to tasks. That's annoying. Alright, erase by value. Let's see. Have an array. Snook now chooses a value in array. Alright, let x be chosen. Then he makes integer. Lining up all. This music is so distracting. Oh. Lining up all the elements of A that are not X without changing the order. Okay. Okay. So we want to choose all values besides X. Okay. So basically, just don't take the largest value, right? Or no. Take the first value such that there's a value less than it. Right? That should be it. Alright, let's see. Alright, so first off, we're reading the size of the array and the array. Now we should make variable x while n is 1 and not x or a of x plus 1 and a of x plus 1 is greater than or equal to a of x. Should do wait, what? No, we just take the first value that is not equal to 0. 0. Okay, wait, let's do this. While x is n, and x equal to a of 0. Alright, so now we see. No, I was right before. Fuck, where was it? Alright, so. So think about the array. We know that, how could we make the array less than it is now? Well, if we take out, like, the first element, if the next element is greater than it, then it will be lexicographically greater. We don't want that. However, if the next element is lexicographically less, then we want that element. we want to take out this element, because then now it would be lexicographically less. Alright, let's see. So now, this should be right. Now let's just do, okay, let's just print out all the elements not equal to a of x. If I is not equal to x, if x equal to -1, that is a of x equal to a of 0, not equal to a of 0. Whatever. I just like to make sure that I am not printing a space at the end. More of like, I don't know. You're allowed to have a space at the end of the input, but I don't like that. If a of I equal x, then if not equal to empty, CL equals 0. This is speed up size, I equals plus. Okay, this should be doing what I want. Two, 1, 2. Let's just input all of them. This wasn't a hard problem, but I took forever wanting to make sure it gets exactly the way I want. Okay, let's just submit this, and it should be good, right? Alright, yeah, easy clap. Let's do the next value, no problem. There are given permutations, blah and blah. Snook is going to extract subsequences. Okay. Here the subsequences must satisfy the conditions below. The length of the subsequence extracted from P and extracted from Q are the same. Okay. BI is a multiple of AI. I see. So basically, we want to like map for each value of PI, we want to map it to a QI. Over and over. Right. Okay. So let me create a new text file, and then let's see, do some drawing for this one. So like we have a P1, P2, P3, 4, P5, etc. And we'll have like Q1, Q2, Q3, Q5, etc. And basically, when we want to go like map, let's say a possible subsequences. Q2 is a multiple of P1, and then oh no, Q3 is a multiple of P4, and Q5 is a multiple of P4. So then we see it basically looks like a matching where each edge like has to be to the right. Maximum value of n is 2000. Oh wait, their permutation. That's probably important. Well, because each value from 1 to n is only n once, how many other values will you go to? Okay, I think a permutation is important because for each number in P, you can just iterate like x, 2x, 3x, etc. to get the corresponding value in Q, right? This is because, you know, as is well known, the sum of 1 over I from I equals 1 to n is around the natural log of n. Well, yeah. So then it would be like n log n, or whatever. So then we store like a DP state of so we go in order, iterate through P1 in order, and then for each value of P1, and then for each Q, we hold like a bit of like what is the maximum value in this at this point, and then we can query the bit for the maximum in a prefix. And then, so then, like for DP of P4, we try each value of each value it can correspond to, and then see like what DP value we can get in the prefix, plus 1, and put it at that value, I guess. Something like that. But we have to make sure we like don't get the same value from P4 twice. Okay. I think I got it all good. So I'll do alright, so maxim, b of maxim, constant int, x equals 2. Alright, let's see. Well, let me just make the bit template first. So then this is adding to a bit. For x plus equal n. That's it. Alright, we need to have this plus 1 because the bit is 1 indexed. B of x equal max b of x. Is this right? Oh, why? Now for the query, x rect 0 or x plus plus x minus equals negative x right is the max of rect. So you don't usually see like a Fenwick tree for maximum queries, but you are able to do it if fine. I guess we should do it like this. Okay, that should be right. Now we do. So basically, I want the array A to correspond to the A value. Now I want F to be like the inverse of B. So like, what position of the array is value I at? Alright, so let's see. So first, let's read an array A. I think I'll want to index it. Well, in that case, then 0 index. So here's what I mean by the inverse, like, instead I see an x and then do f of x equal to I, which means that in array B, the value I is x is at position I, and since it's a permutation, uniquely maps. Now, we just, once again, iterate. Space. Now we need a vector. So remember what I said, that we need to make sure that when we're querying array Q from, like, for a position, we need to make sure that we didn't already put in the DP value of like a, for like a P4 mapping with the earlier Q. So we need to like query the values from right to left, which is why we have to do it like this. Or int is a of I, n is a of I. Q has to be the multiple of P, right? We dot push back J. F of J should be like this. So see, we're iterating over the multiples of A of I. We're putting their positions in V, and we'll sort in, V dot N, reader in. This is how we're doing it from right to left. And for V, we're adding add J do this all right. Yeah. J query plus 1 plus 1 should be like this. So you can see we're taking them. So like first off, the P's are monotonic. So like we're always only getting DP values from a P before a P. To make sure a Q comes before a Q, we're only querying the maximum of the DP values match with somewhere below here, and then adding in this matching. Hopefully that makes somewhat sense. And then now at the end, we just see where the end is. And that should be it. Except we got 2, that's it. What am I doing wrong now? Instead of a bit, we could have also used like a monotonic set or something. But oh well. We already coded this. Monotonic map. But what am I doing wrong here? Oh, got to read in. How do I forget to do that so much? Whatever. Alright, 2, let's go. Make sure all the samples are right. I don't want no dumb penalty. Let's open up this damn next one. How are we doing compared to others? Alright, I think that one's right. And last one. It should be right. It was pretty easy, I thought. Alright, let's go. Come on. Hurry. Alright, looks like it'll work. Okay, AC. Easy clap. Next task, row column sum. Alright, let's go for another easy clap. Have H rows and W columns. This loop is going to write an integer between 0 and k minus 1. Here the conditions below must be satisfied. Sum modulo k of integers. Right. Is AI. Okay. Sum modulo k. So here we have... Why is this... I feel like there are like 1,000 variations of this problem. So you want... like, of course, the most known variation is when it's not modulo. It's the magic square, right? So you have like a grid, put values in, have like a... you need to satisfy like a here, A1, A2, A3, 1, B2, B3. Okay, why is that? Need to satisfy under the modulo, like this row. Here, 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 sums to B1, here, 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 sums to B2, here, 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 sums to B3. And here, 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 A1, A2, A3. Did I do this right? Any other constraints? K is also up to 2,000. It's kind of interesting, I guess. Here we can see the sum. It's 0 is 2, 4, 6. Modulo 3 is 0. 2, 4, 5. Modulo 3 is 2. We have 1, 2, 2. Okay. I'm seeing it. How are we gonna go about this? Alright, so we have these must all be equal to BI. Okay. AI modulo K and BI modulo K. Maximum possible sum. Oh, even harder. Also find the maximum possible sum of integers. I see, I see. Well, first off, we just need to figure out if it's possible, right? And then probably once we figured out that condition, the maximum condition will become apparent. Alright, I am not sure what I'm gonna do for this one. Alright, let's see. Let's just try some constructions. Why does this one not work? Well, forget about the modulo for a second. Like, how do you know if the problem's possible without the modulo? Is the modulo important? I mean, obviously, you can set it up as like a system of equations, right? So we have the system of equations. Well, I mean, say we just make this go up to A. I want the maximum sum too. This is a bit tricky. Come on, need to think of ideas. The problem is, I'm not seeing like any immediate approaches or ideas. If it is possible to write inch. I first just need to figure out if it's possible or not. Why is this one impossible? Let's think about it. So this one has the case. Has 0, 1, 2, and then 1, 2, 3. What are we going to do about it? Why is this case impossible? And how to do it? I'm just gonna write the system of equations and see if that gives me insight. 1, x, 2, x, 1, 3 is equal to 0, x, 2, 1, plus x, 2, 2, x, 2, 3, equal 1. And then x, 2, 3, 1 plus x, 3, 2 plus 3, 3 is equal to 2. Okay? And we have the, like a x 1 1 plus x 2 1 plus 3 1 equals 1. X 1 2 plus x 2 2 plus x 2 equals 2. X 1 3 plus x 2 3 plus x 3 3 is equal to 3. So you have like a, these are your equations. What am I going to do about these equations? I mean, well, obviously, imagine summing all the equations. Of course, the sum for all of these has to be equal to all of these. Like 0 plus 1 plus 2 has to equal to 1 plus 2 plus 3 much. Okay, I'm guessing that. Is that the only condition you have to do? 1 plus 2 plus 3 is 6. Modulo 4 is 2. Maybe that's the only condition you have to satisfy. Let's guess that for now. That'd be a pretty weird. I mean, there has to be more, right? I don't know. Alright, imagine putting like the maximum possible values that can get this 0. So it's like k minus 1. Well, we have like 6 equations and too many variables, right? So let's just put like k minus 1, k minus 1, k minus 1, k minus 1. Okay, well, let's just like assume we have that, and then only control these last few variables. We may need like one more. So for the 0, for the 1, that's unique. All of them over here are going to be uniquely defined by the k-1s. However, then you need a variable that like works for here. Well, the 3 and 2 are different, so obviously 0 plus 1. If these are both the same, then what does that? Assume these two sums are the same, like 2, 0. That means the sum of all of them over here should be equal to the sum of what? Well, this like the total sum minus 0. This is the total sum minus 2. So the difference between these sums is the difference between these, basically. So of course you can't just like put in here naively. Like, can you like just only change these somehow and make it work? Well, yeah. Of course. So why don't we do this? Let's put in all of k-1 up there. And then put in the corresponding values uniquely determined by the k-1s in all like the rows and columns, except for the bottom square. In the bottom square, well, any 2x2 square, because k is relatively small, we're gonna iterate for a variable. Well, it should just be like a... Aren't these like uniquely defined by the everywhere else? This is like four variables, 4 equations. Well, just because the total sum adds up doesn't mean that these ones will, right? Because zero, 2. Okay. Trying to maximize the amount. Need to create equation. Oh no, I'm gonna look at D, and then I'll come back to this. But this basically looks like another constructive, and if you watch my previous streams, you know that I do not like constructive problems. Let's see. From L to R and V, find the number of pairs of integers that satisfy both conditions. L is less than or equal to R, and L XOR L plus 1 XOR blah 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 is equal to V. Well, this is pretty easy, right? This seems easy. So first off, think about, let's say like let's let x prime equal x XOR x minus 1 XOR etc. Then in this case we'd have we need the number of v such that is equal to r prime XOR l minus 1 prime, right? And now it's pretty well known that this sort of x prime function is has a pretty nice pattern. It's different cases based on modulo 4. So look at 0, 1, 2, 3, 4, 5, 6, 7. So start out with 0, 1, 3, 0. And then 4, 4 XOR 5. This 1, 6, 1, 1, 0, 7, 0. So what do we see here? We see that 3 modulo 4 is always 0. 4 modulo 4, 0 modulo 4 is always itself. What about the other cases? 1 modulo 4 is always 1. And then 2 modulo 4 what's the 2 modulo 4 place? It's itself plus 1, right? So n prime is equal to 0 mod 4, 1 mod 4, 2 mod 4, 3 mod 4. So we have, this is a 0. No, this is n, 1, n plus 1, and 0. I think this is right. So now, what we need. So, what are the ways then that we can get v? Well, we need the number of ways for the numbers for say L minus 1 is less than or equal to L less than, strictly less than R, which is less than or equal to R. So let's just iterate over the cases of R and then get the corresponding L accordingly. So if R is equal to 0 modulo 4, we get N. Well, let's iterate over both L and R modulo 4. So for 2 modulo 4, well, based on the values modulo 4, all the bits above the bottom ones are set, right? And then I mean, the bottom 4 bits are uniquely determined just by the casework modulo 4. And now the top bits for 0 and 2 can be whatever you want. So the problem is equivalent to... So you have 4 problems. Well, you have a few different problems. You have do 2 constants XOR together equal V? Or how many numbers XOR a constant equals V? Well, there's only one unique number, right? So the only real problem is for either 2 n's or for n XOR n plus 1, how many pairs are there that equals V within the range, right? And for n XOR n plus, for n and n plus 1 both, you can just completely ignore the bottom 4 bits and only care about the top bits. And then it becomes the exact problem. How many pairs in this range? In a continuous range, you don't have to worry about the modulo anymore. XOR to a given value. Then, let's see. That's probably a problem I've done before. Do I remember how to do it? Where'd my music go? Hello? I did not say to pause. Alright, so let's see. What is the number of pairs? What is the number of pairs of numbers that XOR to the number of pairs x is less than y such that x XOR y equals z? How do you solve this problem? Well, you can probably do similar to like chemistry, where it's like well, we know, what do we know? We know for each value of y, for each value of x, there's a unique y that gives us the correct value, right? But we can't just say like from all x from L to R, because let's say for x from like a L minus 1 to R, how many given number greater than x that is also in the range? How many, for each x from L to R, how many give a pair, matching pair? Do you know? I don't know. Well, yeah, well, we can still solve it like recursively, right? Well, how do we make sure it runs in time? Like, we'd have to recurse. For 1, when the top bit is 1, we split into like 2 DFSs, right? Well, based on the top bit, if it's 1 or 0, we have 2 different choices. Well, what range does Z XOR X fall under? All we need to do is figure out what range does Z XOR X cover. It won't be continuous, right? Right. Will it be continuous? Will it be continuous? Well, yeah, it should be continuous. Is it continuous? Think. Is it a continuous range? Either way, we need to count the pairs where x is less than or equal to y. Well, we can just count the total pairs and divide by 2, I guess. Because the only time where x and y are equal is like if the XOR is 0. So if we have a fixed z and iterate x in a consecutive range, is the range that it can reach also consecutive? is it? Okay. Okay, good. Well, let's think about like an arbitrary. So we'd have like some here. So we'd have 1x or 1 is 0. Why are these? 1, 0, 1. So this would be like 0, 1, 1, 1, 0. When we add 1, these would go here, 1, 0, 0. These would go like to 0, 0, 0, 1. Alright, well those aren't consecutive definitely, so no. Are they? No. They're not. Oh wait. I think I remember something like this. So basically, yeah, you aren't getting a consecutive range necessarily. However, if you split it to where all numbers are between 2 to the x and 2 to the x plus 1, then you are getting a consecutive range, right? Because the top bits are constant, so they'll XOR to a constant value, and the bottom bits are every value in a range. So you'll also get, for the bottom bits, every other value. So that means we can just use a segment tree and get like consecutive ranges that are powers of 2 that like the interval falls under, and then see for each of those intervals we XOR with like a v, and then see how much of the interval falls in the range L to R, because yeah, you get the point. Wait, how do we find the boundaries of... Well, duh. It'll just be the top bits are XOR'd, then the bottom bits still are the 2 to the x range. Okay. I think I can solve this one. I'll code it... How much time do I have? 1 hour 13 minutes. Let me go back to C just a little bit. We're gonna go till the 1 hour mark. If we don't figure out C by then, we're gonna just code D. But it looks a little bit cancer. Why is my laptop not plugged in? I would prefer for it to be plugged in. Okay. Let's figure out... Alright, back to this problem. Go back to this, 13 minutes. Don't figure it out. We code D. Every integer, 0 to k minus 1. How do we know this is maximum? Wait, is there always a... Let's go back to that square idea. Why did I say there wasn't always a solution? That's 4 equations and 4 variables. And are any linearly independent? Are they all independent? They should be, right? Yeah, why don't I just fill in these and then figure out the final values? Oh wait, it's even easier. We don't have to even, we don't have to worry about even like doing like a system of equations at all, because we can just iterate over one of these, over like this value, and all the other values are uniquely determined then. And we set all the other ones to k minus 1 and their corresponding values. How do we know for sure that this is optimal? The answer is, we have no clue. But, we'll do a hopeful proof by AC. what if one of the sides is only 1? Well, that'd be annoying. If n or m is 1, then obviously the thing is uniquely determined. Otherwise, we have a bit of oh no, we're gonna try coding this first and hope for some hopefulness. So let's just put in the inputs first. So here we're reading A, here we're reading in B. Easy. Okay. Read in the inputs. Now, let's see. Let's see if we can see this out. Now remember, we're iterating over 1 value. Why can't n and m be guaranteed greater than equal to 2? I would just make this nicer. If alright, let's just deal with the n or m is equal to 1 case separately. So let's do it. Alright, let's see. So we need to make sure the XOR is all 0. Y equals it's not equal to 1 times I. Times B of I. Ignore my weird notation for testing if it's equal to 1. It's not equal to 1. Yeah, this. If scout return not x plus your y colon. I go for this as well. Yeah, so if like n or m are 1, then of course like it's just like a single array, so all the values are uniquely determined. We just need to make sure the XOR matches up. Otherwise, we're gonna do the thing where we fill it all with like k, and then like k XOR that. But like, how do we know this should be all k, right? Like, what if... Well, like, if we decrease k, how much can we increase x? K minus 1. Is it ever best to not do k minus 1 for all of it? Is it ever best to not do k minus 1? When would it be best to not do k minus 1? So like every time you subtract 1 and k minus 1, you can at most add the amount you subtracted in x, right? Which means that it's always best to just keep this at k minus 1 originally. Is that true? X plus y is equal to x XOR y plus x and y. So if you have x at the maximum possible, to get x plus y maximum possible, decrease that. I don't know. I'm just gonna do like some magic proof by AC because I'm not entirely sure if this is right. So what is the value of this? This is like k minus 1 times what? N minus 1 times n minus 1 minus 1. Let me make this all long. I don't want no overflow like yesterday. First off, we gotta find the XOR 4 times 0. Well. Alright. I guess we don't really need this, do we? Z is equal to k minus 1 times n minus 1 times 1 minus 1. Right. Plus if is equal to 2. If z plus equals n and 1 question mark. Question mark. A of I. No, it should be m and 1. K minus 1 x 1 k. And then we do the same thing. B. Okay. Now we just see if we can find something that works for the final two values. Let's just store this. This just makes it a little easier. Why? Okay, now let's see. XX equal to x XOR y, while y is equal to y XOR Wait, no, 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 no. Why did I do that? Alright, let's see. Let's make sure we're doing this right. So we need to get this XOR equal to X XOR A of I, sigma what? BB XOR equals Y XOR. Okay, so what does this correspond to? This is basically getting that row down here. All of these over here, and all of these over here. Because we need them to see if this value matches up. Hopefully that makes somewhat sense. XX is equal to what? X XOR I, X XOR I, and Y XOR I. What do we need to do? X XOR I XOR XOR A of 1 XOR B of 1. And then if, oh wait, can we just treat this as a 2, but no. Do we need this separate case? I'm not too sure. Now if AA XOR XX is equal to B of 0 and BB XOR YY. A of 0, we do max of ret. I'm pretty sure there's only one solution, but whatever, I'll just do this anyway. Ret is equal to max of ret. I plus XX plus YY plus AA. Hold on, am I doing this right? AA XOR XX. These need to be the same. Hold on, what? AA XOR XX has to be equal to... No, this is... XOR B of 0. This is equal to... this. Now we test if ZZ is equal to BB XOR YY XOR A of 0. We do ret is equal to max of ret. I plus XX plus Y. ZZ plus ZZ. I'm gonna put Z at the beginning. Something like this. Will this work? I have no clue. Let's see. What now? Why? Why do you hate me? Why would I do this? Put the correct variable name is always good. Well, that's not good. What am I doing wrong here? XX. Y. Z. I. Why is it not iterating? Did I forget to read in again? Man. Okay, it's still saying wrong value anyway. Here we're getting 2, 0. Alright, let's see what it looks like. Let's create the grid. We have up here, we're doing 2, 2. No, this should be 3, 3. This should be what, 1? 3 XOR. What? 3 XOR 2 is 1. 3 XOR 1 is 2. Now let's see what we're getting for the remaining values. What are they supposed to be? 0. 0, 1. Alright, 0, 1. And 0, 2. Wish I could read. And then 1, 2, 2, 0. So we imagine putting 0 up here. Huh, why is it not iterating through? I is equal to 3. And MK. What if one of the XOR values that is greater than K? That's annoying. Wait, what am I doing? Why did I start doing XOR? I have no clue why I started doing XOR. Shoot. It should be. I'm so stupid. I have no clue why I started doing this. Alright, this should be K minus M, K minus 1 times M plus K. K minus M minus 1 K minus 1. I'm not really sure how I started doing all that dumb stuff. For some reason. Oh well. This should be A of I, A plus A of I minus what? X, okay. And then we do. Yeah, I'm not really sure where all this dumb stuff was coming in. But also that makes the proof easier for why it's maximal. Alright, yeah. I have no clue how I started doing XOR when it's the sum. Anyway, back to this. Let's see. Let's do W is equal to K plus A of I plus X. Okay. C plus equals W, and then we have to do AA plus equals W, same equals K. Here we're doing same thing, except for B of I minus Y BB. Am I doing this right? Hopefully I'm doing this right. Alright, yeah, now I'm pretty sure that I'm doing this right. Okay, it's A of 1 minus X minus Y 1. Y is equal to 2 times K, B of 1 minus X minus Y. Minus I minus Y minus I. Okay. Now, finally, we do it. ZZ is equal to 2 times K minus B plus B of 0 minus AA minus X. Right? Should be right. And now, is ZZ equal to 2 times K plus A of 0 minus BB. Minus Y. And okay. Can these be on the same line? Sure. Is this possible? Now we say res. Alright. Yeah, I'm not really sure what I was doing before. Huh, all of them are? Alright, first off, let's put our this should be modulo 3. K minus 1 will be 2, 2, 2, 2, and then 2, 0, 2. Now, let's see, here we're putting 2 plus 2 is 4. I, 0. Well, this doesn't seem right. Alright. Two, 4, 6, which is 0. What am I doing wrong? What am I doing wrong? Let's see. What am I doing wrong? We need to figure this out. XX. So we're iterating I. I is here. Now we're saying here should be What? Should be x. X is 0, right? Let me make sure of that. Oh wait. X. Yeah, x should be 0. But it actually... plus a minus 1. Plus 1. So we need to subtract k minus 1 from here. Minus k. Minus k minus 1. Should be this, right? Alright, this is 0. Also, this should be n minus 1. Why is it 0? That's not right. A of 1. A of 1 is 2. A of 1 is 0. So that means it should be not 0. Come on. I'm figuring out which one. I'm figuring out this one. That's the number of m. A of 1 is 0. Minus 2 minus 2 is 4. Let's do a minus 2 instead. Minus x. Which is the same as plus 1. This one should be like this. Now we can get rid of this. Minus x. Why is this minus? This should be minus xx. This should be minus 1y. Oh, this should be not this. Right. V of 0. Minus xx. What are we doing now wrong now? As always, I suck at figuring out. Right, so this is 0. Times 2 is 4. Is 5. Okay, m minus 2 times k 2, 4. 0 minus 4 is 2. 2 minus 2 is 0. What am I doing wrong? Why does it keep pausing? Where is, what am I saying? We have 0. What's A? A should be 0, right? Alright, first off, we drew our diagram different, I just realized. Now we have it. We have this filled up here, I guess. We have this equal to 1. This equal to 0. Setting this equal to 0. 2 plus 2 is 4. 1 is 5. 2 plus 2 is 4. This 1 is 5. 1, 3 is 2. Okay, that looks good, I guess. 2, okay, and then last but not least, 0. Wait, why is it saying this one doesn't work? Should be right. Why is it saying 1 when I'm obviously getting A of 0 is 0 minus 1. It's a BB. Alright, there's a problem. Why is BB equal to 0 when it should be being equal to 1? B of I is equal to let's see, 0. 0 plus 1 is 1. 1 minus 0 is 0. Probably. That's the problem. I never cease to amaze myself at how bad I am. Okay. Hopefully, now this is right. I think this is right. We took way too long on this problem. I'm just gonna simulate it, because like, whatever. I don't care. This better be right. Come on. Give me AC. Don't give me WA. I don't want no W. Fuck. Why? Let's see what happened. Well, we got like a decent amount of AC. Ish. But we did not get all AC. Did we get the second sample right? Yeah. What other case did we miss? We're running out of time. Ugh, I'm not gonna be able to cut that. Alright. You have until 5 minutes to fix this. 35. What am I doing wrong? Age-old question. I do not see what I'm doing wrong. I'm not too rightly sure I'm doing anything wrong. Alright, what? Alright, you have to think. Did I do any stupid mistakes? -2 and -2. Should be n-1 times n-1 minus 1. Well, over. First off, why? X is equal to Y, got your radical. What's that? Well, let's just make this a separate line. Let's see, what are we doing? I doubt like we're getting all the wrong answers just on that single case, right? Is there a penalty in Atcoder? I don't know. I'm just submitting again to see if that fixed anything. I mean, it must have fixed something, right? Well, I think we got a few more right. Right? Let's look at the last one. Improved by a whole 2 cases. Wow. Alright, let's see. No. -2 times k. First off, multiplying by k minus 1. That's the exact same as just doing like k plus 2 minus 9. Minus 1 times n minus 1 times n minus 1 minus 1. A is 1 minus x. What am I doing wrong? Which part is wrong about this idea? 2. This ends up with the same solution as up here, I guess, right? Except these are flipped. Also, we're missing the 1-by-1 case. Let's see if we at least get one more case. If there's like a penalty, actually I think there is a penalty. Well, we're just killing our penalty. I don't really care. I'm not too sure what is wrong. Let's see. Yep, we did get this case. Alright, so we're getting up to here. And all of a sudden, we're getting all these wrong answers. So, I don't know. Looks like we're kinda right, but not exactly. Which part is wrong? Is our whole idea wrong? Or is just the... are we doing like the little brute force part wrong? So we have this is equal to... I'm not sure why we do it like this. I'm gonna flip these around. Because I want to. That shouldn't change the answer. Oops. Oops. Alright, let's think about this. This is A of I plus K minus 1 for all of year. So why do I even hold this and this? That's pretty stupid. We can literally just do plus n minus 1 n minus 1 no, plus m minus 1. This one is plus m minus 1. This is, wait, A1. M. N. Oh, well, that was... What did I mess up now? Should be M minus... No. 2. Minus 2. Minus 2. There we go. Yeah, so that's just all these like little K minus 1s plus this. Then A plus equals this. Z plus now this is equal to 2 times K plus B of 0. Minus XX minus XX minus AA minus YY minus BB. Yeah, I'm not sure what I'm doing wrong here. Like, can't waste. Okay, yeah, we're really running out of time for this. And it's not exactly super easy to cover. Okay. You're gonna have to just go for it. you sure you can't solve this? Come on, we're so close. 12 and 12. Is there any overflow? I'm not sure. Yeah, I'm not too sure what I'm doing wrong here. I thought this looked right. Oh well, we're gonna code this instead and come back to this. Will we have enough time to code this? Probably not, but we're gonna try anyway. Because it looks more fun than C. I don't really like C. It's not my type of problem. Let's see. Mod 998 244 int, what's this int again? Because, yeah. We're gonna need a segment tree. Oh, segment tree, oh, segment. Segment tree, oh, segment tree. You are the segment tree. How do we get the... we need the... We're just starting the line into the signature. That's literally all we're doing, right? Do we even need it? No. We don't even need this. We're gonna do like the segment tree thing, but we're not actually gonna code a segment tree. This. Alright. If R is less than M, or L is less than N, or R is less than N, or L is less than M, L is greater than. If, what? If L is less than N, and R is greater than M, no. L is greater than N, and R is less than M, P dot push R. Defs mid is R 2 defs mid defs. So as you can see, this is doing exactly what a segment tree does to get the intervals that N to M covers. So we're doing like what DFS. So first I see N K, and then DFS 0. Alright, you're maybe wondering why I'm doing N. So remember I said we need to be able to get rid of the, like, we'll like only look at the bits above the bottom two, because we're looking at the modulo 4. So let's see. What is this? Sound of 60. Constant. Let's do. Alright. This should be getting the intervals. Now we just have to iterate over the cases. Alright, remember the cases I laid out. Where is it? Over here. So we need to iterate over... First off, let's iterate over the cases for R. R can be between N and M inclusive. So, first let's do... Alright, if A is greater than or equal to N minus 1, equal to 3, 4, R is greater than N minus 1, N. Less than M, and how should we iterate over the cases efficiently? Should we just like casework it all out? Ugh, that's 4 times 4. That's like 16 days. I'm gonna count all this. We need an easy way. And cases M. Alright, we're gonna make a function f for dealing with when it's a constant. 1 month plus equals R red plus equals F. We're gonna call this F, and we're gonna say F is equal to n. Wait, but how do we make sure the pairs are such that it's less than? Okay, maybe this, like, dealing with the cases is a pain. Alright. Okay, never mind. Scratch this. Okay, alright, yeah, I'm running out of time. My best bet is probably C. I feel like this should be right. Let's see. I definitely don't have time to code D, so I need to see if I can fix C really quick. Can I fix C? Well, something about my strategy must be wrong, I guess. Because, like, if it's working for the smaller case but not the bigger, it just must not be the maximal solution. So what could I do different in my strategy? Using k-1. That seems like it'd always be optimal. Already? Because you could, like, change the value here. Well, what are you gonna do about that? Alright, what am I gonna do about this in the 10 minutes I have left? K is equal to 3. Why would I not put k? When's a case that I would not put k-1 for all these places? So why would you not put k-1? You'd not put k-1 if you wanted over here to be bigger. Like one of these over here, I guess. Like this is determined from this, right? Subtract this from this. 1 from this, that can add at most 1 here. Subtract 1 from this, that can add at most like 1 here. Oh wait, subtract 1 from this, that can add 1 here and 1 here. But then it's still not making sense. I mean, it needs to be possible, right? It's not like you're gonna just... Alright. I don't know. I don't have any bug. 8 minutes? We need to think of something. Alright. What are we gonna do to fix this? We can't just brute force a 2x2 square and let everything else be cables. So what other strategy do we have? What other strategy? Well, like, okay, we must not, like, explicitly place the values then, because it seems like it'd be impossible, right? No, based on these, decide these exact values. Okay. What's the criteria for it being a square? For it, like, being valid? Let me put this in. We know that this plus this is equal to here. So it's this minus this. This minus this is equal to this. This minus this minus here. Here. Wait, hold on, that's interesting. This middle square is being cancelled out, I guess. Here. Here, minus here, minus here, minus this, here, here, here. I'm getting tired. What is it? 12:15 a.m. It's not even that late. Here. I think this middle square is being cancelled out when you're subtracting. So then it's basically like some constant, these are equal. Well, what is the values of these? 0 plus 2 is 2. Then 2 plus 2 is 4, plus 1 is 5, modulus 3 is 2. But 5 is the bigger one. So we need to take at least 2 times 4 is 8. What's it? 8 times 2 is 10? 16. 16. Oh. I think I got it. Alright, I'm gonna do some great proof by AC stuff. Alright. Time for great proof by AC. Are we out of time? 3 minutes. 3 minutes for my proof by AC. Alright, so basically I'm just bounding it by. We have to subtract at least the greater of these. Wait. Alright, this should be k minus 1. 0. Plus equals b. Yeah, x percent k is not equal to y percent k. Otherwise we do x is equal to x is equal to, we need to do, how much would we need to subtract to get that out? Do k times k minus 1 times n times x, y is equal to k minus 1 times n minus y. See how k minus 1 times n times m minus mu y. Next. Alright, this probably ain't gonna work, but it's my last effort of like bounding the answer and doing some proof by AC. Come on, it'll. Shoot. Come on. What do we need? What do I need to subtract it? K minus 1 times that. Alright, so it's like K minus 1. Well, let's let it go. So we're setting everything into well, I have no clue why that would work, but it makes the right answer. So we're gonna proof by AC time. Yeah, okay, that doesn't work. I would have been too lucky. But I'm not sure what to do then. We know that the modulos have to be the same. So we want to subtract the minimum amount possible. Okay, yeah. It looks like we are not getting it. Well, that's yet another disappointing virtual. Only 2 problems. Oh no, we got like, I feel like we got a decent amount of insight into D, but we didn't get like all the way there. And then a C, we just didn't get all the way. Oh no. Let's look at the solutions. Let's see. Well, what did we miss for C? Wait. Shoot. Was it really this? So if I just took out this line and submitted, would this have worked? No. Wait, what is it? What is the editorial saying? Z is equal to max of the sum of Ci and the sum of Di. I'm saying H times W times M, that's K minus 1. Hypothetical. X Wait. So what is this wrong with this? Isn't this exactly what it's doing? K minus 1 times N times M minus max. Sum of these, the sum of these. If x percent K is not equal to y percent K, max C of I. Sum of C of I. Wait. No. If we add this line back in, K minus 1 times N minus X. That's the exact amount we need to reduce it. What was wrong? What was wrong with my idea? Alright, let's see. Let's see what they did different than me. A of I is equal to K minus 1 times M sum of what? K minus 1 times N times M. Wait, why are they replacing A of I like this? K minus 1 times W? Y times W? Huh? Find the amount we need to reduce the modulus. Oh, you idiot. Wait. No. No. Oh, I see. Alright, our like last little idea was pretty close. Let's see for D. How close are we for D? Alright. Yep, this is what I said. Wait, 4x. Huh? Oh, did I get these cases wrong? Oops. Huh? Okay. Wait, are you sure that's right? Did I seriously mess up the casework for that? Alright, 0. 0 XOR 1 is 1. 1 XOR 2 is 3. 3 XOR 3 is 0. Oh wait, this is XOR K minus 1. Okay. This k minus 1 is 0. Up to here. It's 4. Okay, yeah, sure. Oh, I think we basically had it more or less. It was just some casework. Oh well. Look. Alright, I don't know. I think, like, if we had like 10 more minutes, we would have got C. And then we probably could have got D in like, I don't know, 30 minutes. But, that's all for today. A little disappointing. But, the problems were, well, the first two were boring. C and D were interesting enough, I guess. They weren't like my favorite, especially C. But they weren't that bad either. You know, they were fine. That's all for today. Adios.